Hi, this is Alex from devstories.eu. Langgraph, episode 17 of 18. A Python script running successfully on your laptop is not a production application. If you try to run stateful agents by executing standalone scripts, you will inevitably hit a wall when it is time to scale. To solve this, we are looking at application structure and deployment readiness. When you first build a langgraph agent, you probably prototype it in a Jupyter notebook or a single Python file. You define the nodes, connect the edges, compile the graph, and call the invoke method right there in the same file to see if it works. That is fine for testing. However, a production server cannot read your mind. It needs a standardized way to serve that graph as an API, install its required packages, and inject environment variables. To make your prototype deployment ready, you must organize your code into a clean directory structure. Let us say you create a new folder named My App. You move your Python code out of the notebook and into a clean file inside this folder. Next, you add a dependencies file, typically requirements.txt. Finally, you create a configuration file named langgraph.json in the root of the My App folder. The langgraph.json file is the core blueprint for your application. When you use the langgraph command line interface or deploy to a production environment, this configuration file tells the underlying system exactly how to build and run your project. It requires three main pieces of information regarding dependencies, environment variables, and the graph entry points. First, you declare your dependencies. This is just a path string in the JSON file pointing to your requirements file. It ensures the deployment server installs the exact Python packages your agent relies on, preventing missing module errors in production. Next, you define the environment string. This points to your .env file. Stateful agents always need secrets, like database credentials or model API keys. Pointing to the environment file ensures the runtime securely loads these keys before attempting to start the graph. This is the part that matters. The third requirement in the configuration file is the graph's mapping. This tells the server exactly where your compiled graph lives in the source code. It acts like a dictionary. You assign your graph an ID, which becomes its official name in the generated API. Then you map that ID to a specific Python module and variable name. For example, you might map the ID customer support agent to the string agent.py::compiled graph. The server looks at the agent.py file, finds the variable named compiled graph, and loads it into memory. This structure requires a deliberate shift in how you write your code. Beginners often run graphs via standalone Python scripts that execute actions as soon as they are run, but the langgraph runtime relies on langgraph.json to expose the graph dynamically as a web service. It does not run your script from top to bottom. It only imports the compiled graph object you specified in the configuration file. Because of this, your Python file should only define the nodes, connect them, and assign the compiled graph to a variable. You must remove leftover testing code at the bottom that manually invokes the graph. If you leave testing code in the file, it will execute during the import phase on the server, causing deployment failures or unwanted API calls just from starting up the service. By explicitly declaring your dependencies, environment, and graph paths in one central JSON file, you separate the definition of your agent from its execution, turning a local script into a robust, deployable service. That's all for this one. Thanks for listening and keep building.